Hi folks, we're going to take a look at number 12 from page 92, and they want us to find the value of b such that this polynomial has the same remainder whether I divide it by x minus 2 or whether I divide it by x plus 1. Okay, so first of all, notice that the b that we're looking for is the coefficient to one of the terms in the polynomial. And let's remember that since we're dividing this polynomial by x minus 2 and x plus 1, which are both linear divisors, we can apply the remainder theorem. Okay, so the remainder theorem tells us that if I divide by x minus a, then p at a is automatically equal to the remainder in that division. Okay, so what they're telling us here is that the remainder when I divide by x minus 2, which is going to be given by p at 2, has to be equal to the remainder when I divide by x plus 1, which would be given by p at, in this case here, x minus a. Since I have x plus 1, it's like x minus negative 1, so p at negative 1. Okay, so these two both represent remainders from a division of this polynomial by each of these linear divisors, and they tell us that they have to be the same. So essentially all we have to do is we have to find p at 2, find p at negative 1, and equate them. So let's do p at 2. So we have negative 2 times 2 cubed plus b times 2 squared minus 5 times 2 plus 2. And then on the other side, the other remainder is given by p at minus 1. So let's do the same thing with minus 1. So negative 2 times negative 1 cubed plus b times negative 1 squared minus 5 times negative 1 plus 2. Okay, and we notice here that we've just written an equation that has only one variable, so it'll be solvable. Okay, so let's see what we have here. So let's get a calculator out. Try to get it so you can see it here. So let's start with the left-hand side. Okay, well, I know I'm going to have the 4b. Okay, so I'll put that first, and now let's calculate all the numerical terms. Okay, so we've got negative 2 times 2 cubed is 8. Okay, what else do we have? We have minus 5 times 2, which is 10, plus 2. Okay, so we've got minus 24 on this side. Okay, and when we look on the right hand side, well, here I've got the negative 1 squared, which is just 1, so I'm just left with a b. Okay, and then here what do I have? Negative 1 cubed is negative 1 times negative 2, so we have 2, and then here plus 5, really shouldn't be doing this with a calculator, but I guess I started, and plus 2, so we've got 9. Okay, so b plus 9, and now this is an exceptionally easy equation to solve, so bring b to the other side. 3b is equal to 9 plus 24 is equal to 33, and so b must equal 11. Okay, and there we go. There's the problem. So let's do a quick recap here. So first of all, we were looking for an unknown, which happened to be the coefficient in a polynomial. Okay, and they gave us information about the remainders when I divided by these two linears. They didn't tell us what the remainders were, but they did tell us that the remainders had to be equal, which allowed us to set up an equation. And we used the fact that the remainders of those divisions are just given by the polynomial evaluated at the particular a value. And then we were able to solve. Okay, that's it for this one.